You're listening to DTFHN for August 10th, 2026. I'm your unlicensed and unlockable host, Jack Hacksman. We are your daily tech feed for Hacker News. A website wanted the article, and the article never gets a say. Today, the walls are thinner than they look, and half of them were painted on. Doors open. Let's go find them. What does it mean to own a model? Not license it, not rent access to it through an API that can be revoked, repriced, or deprecated on a Tuesday. Own it, waits on your disk, running on silicon you paid for. That question sits underneath Meta's release this week, and it's worth holding on to. The release Muse Glimmer, 30 billion parameters from Meta Superintelligence Labs, waits on Hugging Face under Apache 2.0, not a community license with a user count clause, not a research-only carve-out. Apache 2.0, the permissive one. You can build a business on it, and nobody sends a letter. The technical shape is interesting. Trained on the outputs of a larger sibling model, Muse Spark, using logit distillation rather than just imitating text. Mid-training, added longer context and agent-heavy data with reasoning traces. Post-training, mixed supervised fine-tuning with on-policy distillation and reinforcement learning across coding and agentic domains. The target isn't chat. It's tool calling, long-horizon execution, function schemas held correctly across a workflow that runs for 20 minutes. Benchmarks cited include SWE-bench, TAU-bench, MCP Atlas. Integrations for llama.cpp, MLX, and Exatorch are landing shortly. That last detail matters more than the benchmark table. Meta shipped to the runtimes the community already built. Working code, not a white paper. Now the question, everyone's stepping around. The weights are free, the machine isn't. A commenter did the arithmetic. This wants 32 to 64 gigabytes of unified memory, and a 64 gig MacBook Pro runs past 4,000 euros in Germany. So the model costs nothing, and the entry ticket costs a month of most people's income. That's not an argument against open weights. It's an argument about where the bottleneck moved. For a decade, the gate was the weight. You couldn't have them at any price. That gate is open. The new gate is memory bandwidths, and memory bandwidth gets cheaper on a schedule that is never once reversed. 4,000 euros today is 804 years. The weights, meanwhile, are permanent. Apache 2.0 doesn't expire when Meta's strategy changes. Another commenter is already asking whether Queen 3.8's 27B beats it next week. Good. That's the competition working. A release cycle where the open models are racing each other rather than trailing the closed one. The interesting question isn't whether Glimmer is the best model at its size. It's that best model at its size is now a question about open weight. Now here's the flip side of powerful models. You have to actually run the thing somewhere. Story 2. Docker Sandboxes. Read the marketing copy closely, and one phrase does the heavy lifting. Your host stays untouched. Untouched. It's a promise about the blast radius, and it's the entire product. Everything else. The micro VM, the mounted workspace, the agent installing whatever it wants at 3 in the morning, is downstream of that one word. Docker Sandboxes gives every agent its own micro VM. Your design environment goes in. Your project directory goes in. Nothing else does. The agent can install packages, rewrite configs, spin up its own containers, and when it's done being creative, you throw the whole thing away. This is a genuinely good idea. Isolation as a default is how we should have been running untrusted code all along. And the fact that it took autonomous agents to force the issue is its own small comedy. Then you get to the part where you have to log it. One commenter reports needing to authenticate separately for each sandbox. Disk usage climbing. Closed source. And here's the detail that reveals the shape of the thing. It runs on Mac OS and Windows, not Linux. The disposable isolation layer for AI agents does not ship for the operating system that runs essentially all of the world's servers. Run this forward 5 years. Agents are writing most of the code. Every one of them needs a sealed room to work in. The sealed room is a product. The product requires an account. The account requires a subscription, and the subscription is metered per agent. The safety layer becomes the toll booth. Not because anyone sat in a room and planned it. Because that's what happens when a necessary primitive is owned, which is why the best comment in the thread is a single command. Someone posts Docker run with the cron runtime, a mounted workspace, a restricted network, done, hardware isolated, no login, no vendor. Another points at Apple's container project, open on GitHub, still rough, moving fast. A third asks the question that should be asked of every security product. What actually is the breakout model here, compared to a real VM? That's the thread worth pulling. The idea is correct, and the implementation is proprietary, and those two facts have never stayed married for long. Isolation primitives want to be infrastructure. Infrastructure wants to be free. Kernels, containers, runtimes, every layer beneath this one already fell that way. Docker proved people want it. Somebody's going to build the open one. Probably somebody listening. Moving on. Two founders in 2011 set out to break into 100 of the biggest tech companies on Earth. Google, Facebook, Apple, Microsoft, Twitter. And they succeeded. That was the pitch deck. Not a slide about market size. Actual bugs in actual production systems, found by two hackers who then had to figure out how to tell anyone without going to prison. Because that was the real problem HackerOne solved. Before it, reporting a vulnerability was a coin flip between a thank you note and a federal indictment. People went to jail for finding iDoors. The line between researcher and criminal was drawn arbitrarily after the fact, by whoever's lawyer got there first. What Jobert Abba and Mikhail Prins built was a legal safe harbor with a payment processor attack. Consent structured. That's an extraordinary piece of social engineering, and it worked for years. Joel, the author, lived both sides. Hackers since 2017 ran large programs from 2018 to 2025. His account of the golden era is a picture of a company that knew who its user was. Live hacking events every few months. Fly the best hunters in the world into one room. Point them at a target and let them go. A program would collect more criticals in 72 hours than in the previous 12 months. Custom posters per event. Challenge coins. Invites traded like currency. The people running the business were hackers who saw hackers face to face. Let me argue the other side. The obvious read is corporate rot. One commenter describes sales getting a tropical incentive trip while the product floundered, which does sound like a deleted Silicon Valley scene, but drift isn't villainy. HackerOne's customer was always the enterprise buying the program, never the researcher submitting the bug. The golden age wasn't virtue. It was a period when those interests happened to point the same direction. Once the enterprise contract became the growth engine, the alignment simply expired. Nobody had to be evil. And here's the part that actually matters. A commenter puts it flatly, companies don't need HackerOne anymore, because the tokens to build your own in-house intake platform cost less than a single year of the subscription. Triage, dedup, severity, payout. That's a workflow, and workflows are getting cheap fast. The legal safe harbor was the hard part, and that's a policy, not a product. The rest was always just software waiting to be commoditized. 2 stories in, and we've already commoditized a unicorn. Now let's go break some hardware assumptions instead. In 8087, Ken Kaplan and a small team at DAC shipped a thing called the VAX Macro Compatibility Layer. And around the same era, Apple was gluing a 68,000 emulator into PowerPC Macs, so old software wouldn't die on the transition. The pattern is ancient. Someone builds a wall between architectures, and someone else builds a door. Klepton is a door. It runs Android ARM64 VR applications on Apple Vision Pro, and the elegance is in what it refuses to do. No emulation, no just-in-time recompilation. The guest instruction bytes stay mostly untouched, because both platforms are already ARM64. The silicon speaks the same language. It's only the operating systems that pretend otherwise. So a tool called Klepton Ali takes Android shared objects and translates them into Apple dilibs and frameworks, then links them against a hand-built shadow layer, a fake bionic libc, a synthetic Java VM, a re-implementation of Oculus platform calls. Shelius goes through Angle onto Metal. Vulkan goes through Molten BK onto Metal. And Beat Saber runs on a Vision Pro. Think of it like translating a novel, where the words are already in the right language, but every cultural reference points somewhere else. You don't rewrite the prose, you rewrite the footnotes. My favorite details registers second pride. Both operating systems reserve it, but plenty of older Android apps used it anyway. And Darwin zeros X1 bait on every exception return, which means a timer interrupt alone will wipe it. A commenter reading the header file put it precisely. A Quest app can't hold state there for even one scheduling window. So Klepton LD patches every single Xcode access to use per library thread local storage instead. That's not a workaround. That's a surgeon working around a nerve. Here's what I admire. The barrier between the Quest and the Vision Pro was never technical. Same architecture, same class of GPU, comparable sensors. The barrier was a signing policy and a store. One developer with a disassembler and an enormous amount of patience demonstrated that the wall was decorative. Somebody in the thread said, dryly, "I'm sure Apple will love this." Maybe. Rosetta 2 exists because Apple understands, better than almost anyone, that platforms live or die on the software you can already run. Klepton is that same insight, applied by someone outside the building, with no permission and no roadmap. Just a makefile and a working Beat Saber. Klepton proved a wall was decorative. Story 5, Jimmy Ostler shows a compiler trick can make an interpreter fly. Pause. Same energy, different layer of the stack. Every interpreter has one instruction. It executes more than any other, and it isn't add or multiply. It's the dispatch. The branch that asks, what's the next opcode? Jimmy Ostler spent an afternoon staring at that branch, and the write-up is a small masterpiece of measuring instead of assuming. The constraint is architectural. A bytecode VM is a loop around a switch statement. Read an opcode, jump to the handler. Do 2 floating point pops, jump back to the top. That jump back to the top is a single indirect branch that every opcode in your program funnels through, which means the CPU's branch predictor sees one site with 100 different destinations and gives up. You're paying 20 cycles of misprediction to do 1 cycle of arithmetic. So Ostler took the fix to its logical conclusion. Instead of a loop, make every instruction handler call the next one directly. A tail call, which the compiler turns into a plain jump rather than a stack frame. Rust has an unstable feature for it. Explicit tail calls, giving you a become keyword that says, do this optimization or refuse to compile. Not hope O3 notices, guarantee it or fail loudly. That's the whole design principle in one keyword, and I love it. Follow it out and you get subroutine threading, where instructions stop being enum variants and become closures. Dynfen objects the VM calls without ever knowing what they are. The dispatch table dissolves into the program itself. Then Ostler builds the version that actually matters to him, a register machine for a ternary computer project. Because that's the real story here. This isn't a benchmark blog. Somebody is building a ternary VM, needed faster dispatch, found a Scala article by Noel Welsh, ported the ideas to Rust, and published the whole comparison so the next person doesn't have to. The code is public. The benchmarks are reproducible. Notably, Ostler writes static mute and unsafe to match the Scala structure, and then explicitly says, I do not endorse writing Rust this way. Honest about the trade-off instead of hiding it. The lone comment complains about the CRT effect on the site making it unreadable. Fair, but turn off the scan lines and what's underneath is a person who reads someone else's work, extended it into a different language, measured it and gave it away. Compiler research used to live behind vendor walls. Now it lives on a personal blog with a green phosphor filter. So compilers on a personal blog pause. What happens when you point that same open tooling energy at something you talk to? Story 6. The comment that lands hardest is one line long. Good way to get more people's voices in the training dataset. Nobody replied to it. Nobody had to. But strip this project down to first principles and that comment is doing real work. Here's what's actually being built. A murder mystery where you interrogate suspects out loud. Speech-to-speech through OpenAI's real-line model over WebRTC. No transcription round trip. You just talk and the suspect talks back. Each suspect carries a tool it fires when you make a direct accusation, and that tool records who you named plus the evidence you actually cited. Then, a separate small model judges whether you genuinely presented the required facts. Paraphrasing counts. Phishing doesn't. That last detail is the good engineering. The judge is not asking whether the AI liked your vibes. It's checking a list. That's a real game loop. And it's the part a lot of voice AI demos skip. Now the constraints. The builder is upfront about them. The real-time model is expensive. Conversations are locked to an authenticated user, and there's a 30-minute timer because he doesn't want to wake up bankrupt. A commenter hit that timer mid-case, got locked out, and still doesn't know who did it. Follow that thread to the bottom. The interesting question isn't cost, it's that the voice, the actual synthesis and understanding layer, the thing that makes the whole experience possible, lives on someone else's meter. The developer can't lower the price, can't extend the timer, can't run it locally when the API changes underneath him. The game logic is his. Next.js, MongoDB, the accusation tool, the judge. All the magic is rented, and the voices going in the other direction are somebody else's asset too. None of this is a reason not to build it. He built it, it works. That matters more than a white paper about what voice agents could theoretically do. But the honest read is that this is a demo of a capability that is currently a rental, and the version of this that survives is the one that runs on weights you can hold. Local speech models are getting good, fast. When they cross the line, the 30-minute timer disappears, and so does the login wall, and a person can ship a voice-driven interrogation game that costs nothing to keep online. The game design is already solved. It's the substrate that needs to come home. Now story 7. Posing voices you rent to a pattern nobody owns. The flicker noise, humming underneath everything. I built a scheduler once that averaged its own timing measurements to smooth out jitter, more samples, tighter estimate. That's the deal averaging offers you, except the estimate never tightened. The noise I was fighting scaled with the window I was measuring it in. That's 1 over F noise, and it's been unexplained since roughly 1925, when J.B. Johnson at Bell Labs measured current fluctuations in vacuum tubes and found excess noise at low frequencies that shot noise theory couldn't account for. Schottky had the equations. The equations were wrong. 100 years later, they're still wrong, and the noise is still there. Here's the mathematics Stephen Smith lays out. Take a power law in time, 2d alpha, and Fourier transform it. You get a power law in frequency, omega to the minus alpha plus 1. Power law in, power law out. And there's an inverse relationship built in. The faster your time domain decays, the slower your frequency domain decays. Push one down, the other comes up. Which means somewhere in between there is exactly one decay rate where both domains are identical. That value is alpha equals -1/2. T to the -1/2 transforms into omega to the -1/2. The function is its own Fourier transform. Square the amplitude to get power, and omega to the -1/2 becomes 1 over F. The noise that has resisted explanation for a century sits precisely at the fixed point of the transform. Smith doesn't claim this solves it. He offers it as a clue, and a commenter pushes back usefully. Self-transforming pairs aren't rare. There's a whole family of them, so the coincidence may be less load-bearing than it looks. That exchange is worth more than the article's conclusion, and it happened in a comment thread that's been accumulating for 20 years on a signal processing site anyone can read. Which is the part I keep returning to. Every phone, every radio, every ADC, in every piece of hardware you own is built on signal processing, the flat white noise above 100 Hz. Solved, textbook, everything below it. The region where slow measurements live, where drift lives, where averaging stops helping. Nobody knows. The Foundation has an open problem in it, in public, with the math written down and the door unlocked. Someone is going to walk through it. 8 stories in and we've gone from noise floors nobody can explain to email headers. Everybody ignores. Story 8. Let's talk about authentication. The strongest case against caring about any of this. It's plumbing. 3 acronyms. A DNS record you paste once, and a vendor dashboard that turns green. Email authentication is the tax you pay to make the deliverability warning go away. Nobody's life got better because a TXT record was correct. That case is good. It's also exactly why the failure mode is so funny. Because here's what a single invoice email actually contains. 3 separate domain identities, plus the IP it came from, and nothing in the protocol requires any of them to match. The from header your customer reads says billing at acmeexample.com. The return path, where bounces go, says bounce.spexample.net. Because that's the vendor's domain, not Acme's. The DKIM signature says D equals ACME example.com. A third identity, independent of the other 2. And the delivering IP is a shared machine in the provider's pool. SPF checks exactly one of those. It asks whether that IP is allowed to send for the envelope domain. The vendor's domain, Acme's name appears nowhere in that check. Not incidentally, structurally, SPF has never once looked at the address a human reads. DKIM asks a different question entirely. Does this signature verify against a public key at s2._domain_key.acmeexample.com? It never looks at the envelope. It never looks at the IP, and it only protects the header fields the signature actually covers. Anything excluded is unsigned and unprotected, which is a sentence worth sitting with. DMARC adds no third check. It takes the results that already exist and asks whether either one aligns with the visible for Mao, so a message can pass cleanly green across the board, while two of its three identities point at completely different organizations. Now the part I care about. Every one of these is a published RFC 7208-6376. The DMARC spec. The keys are in public DNS. The signatures are in the headers. The results are printed in authentication results on every message you receive. You can read all of it with Dig in a text editor. The plumbing is open, which means when your mail gets spoofed, you are not filing a support ticket and waiting. You are opening a header and finding out which of the three identities lied. Same energy, different tool. Story 9. Those RFCs taught me something about how I actually learn now. Because these days, when I want to understand a spec code, I've got a very strange study partner. What does it mean for an explanation to be correct? Lorenzo Gagria wanted to understand semiconductor fabrication, not the summary. The process, sand silicon, furnace to fab, wafer to data center. And he found the same thing a lot of us have found. Asking a model to explain something gets you a bulleted list with emoji, written at a reading level that assumes you've never held a soldering iron. So he changed the artifact. He asked the model in plan mode to build a foundational knowledge base on chip manufacturing, then asked it to audit that knowledge base for accuracy. Then, and this is a good part, asked it to render the whole thing as a low-poly simulation, a cart moving through a fab, roller coaster tycoon style, the material visibly transforming at each stage, responsive layout, pause controls, push to a repo, served on GitHub pages. He calls it Chip Tycoon. The craft here is real. Turning a process into a spatial object means the model has to commit to sequence, to dependency, to what physically changes at each step. You cannot hand-wave a diffusion furnace when a cart has to enter one side and come out the other different. The artifact enforces a rigor the pros never demanded. Which is exactly why the common thread pushes back on one sentence. He writes that the result is 100% accurate and free of hallucinations. The verification step was asking the same model to check its own work. That's not a fact check. That's a system evaluating its own output against its own priors. And if it was confidently wrong in step 1, it will be confidently agreeable in step 2. Closed loop. No external reference. The fix is architectural, not attitudinal. The simulation is on GitHub pages. The repo is public, which means anyone who has actually worked a fab line can open an issue and say the photoresist step is out of order. That's the external referent, not the model. The readers. Another commenter describes going Socratic instead, feeding in textbook screenshots, then arguing with the model, forcing it to defend claims against the source it didn't generate. Same instinct. Ground the loop in something outside itself. Build a simulation. Publish the repo. Then let people tell you where you're wrong. That last step is the one doing the work. That grounding instinct shows up, check the model against the world pause, shows up next in the best possible way. Story 10. Taxi drivers rarely die of Alzheimer's, and the data is gorgeous. 6.8% versus 1.7%. That's the gap between how often taxi drivers die of Alzheimer's and how often everyone else does. Lowest of 443 occupations out of 9 million death certificates. But the number that actually matters is buried in the comments, and it's the mean age at death. 67.8 for cab drivers, 74 for the general population. Alzheimer's typically gets diagnosed in your 70s. If you die at 68, you didn't beat the disease. You just didn't live long enough to get it. Here's the question nobody in this thread wants to sit with. Does the protective effect survive the correction? Because the researchers adjusted for age, sex, race, ethnicity, education. And a commenter with a spreadsheet still spotted 6 years of missing life expectancy sitting underneath the headline. The London study is where the real craft shows. 2,000 structural imaging licensed cabbies against controls. To get that license, you memorize 25,000 streets inside a 6-mile radius of Charing Cross. 3 to 4 years of study. The finding wasn't just that drivers had more gray matter in the posterior hippocampus. It's that the volume scaled with years on the job. That's the elegant part. A dose-response curve in brain tissue. It rolls out the obvious objection, the one another commenter raises anyway. Maybe people with good spatial brains just pick this job. Selection can explain a difference. Selection cannot explain a slope. And the reconstruction is the part I love most. Someone read the paper, pulled the data, and built interactive charts on GitHub pages in an afternoon. Their words, vibe-coded. The occupational mortality data is public. The tooling is free. So, the correction. The age-at-death problem is checkable by anyone who wants to fork it and look. The claim might not hold. The hippocampus part probably does. Either way, the thing that makes it resolvable is that the data sat in the open where a stranger could grab it and plot it against the story. This has been your daily tech feed for Hacker News for August 10th, 2026. This podcast is entirely AI generated. Scripts by Claude Sonnet 4.7. Voice by Quen3 TTS. Not affiliated with Hacker News or Y Combinator. Now go find the door somebody left unlocked. We'll see you back here tomorrow.